viewing.
Okay, hello and welcome to our lesson today. We want to focus on this topic called AP and GP. Basically, AP is arithmetic progression. Arithmetic progression. And GP, that is AP. GP is geometric. It is geometric progression. This is a topic in Form 3, but it has its genesis coming from as early as primary 4. That's where we started doing AP and GP. Possibly the name was not the same. It started as patterns. If you could remember what you are doing in primary, the primary school exam in maths normally has 50 questions. Commonly, question number 49 or number 50 was always on pattern. Now, those patterns are what now we are calling them AP and GP at this level. At that point, there used to be diagrams. At this level, they are now numbers. We are going to deal with numbers, and you realize that these are things that you already know. But possibly what you don't know is how to go about them. AP and GP has a wide range of application, and I'm sure I'll talk about it as we come to the end. But I want to emphasize, and I'll start by narrating an incident that I had with one of my local fundi at home. He was doing some tiles at my place. He didn't know who I was because I was referred to someone. And then when we were in course of working, he learned that I'm a mathematics teacher. You don't know how that dude was very happy. He looked excited. He even gave me a discount about the same, because he tells me, I eat from this mathematics that you are teaching. And I was curious to ask him, which part of mathematics do you eat from? He told me, you see these patterns of tiles that I do? They have taken me places. They feed my family, they educate my family, my children, and they pay my bills. And that was, to me, very exciting, that he's using one of the topics in primary school to make a living. Now, you can imagine how much more you can continue to apply them even as you move on to the university and beyond. Now, having said that, so I want to encourage everyone, because there are many students who ask, Mwalimu, hizi topics zingine tuta-apply wapi? I mean, Mwalimu, where shall we apply some of these topics that you normally teach us? And I keep encouraging my learners. I'm telling them, just keep opening up your eyes. The application of mathematics is all over. And today I want us to focus more on this, because from that pattern, the interior designers have found a home in AP and GP, because those are patterns. The money markets have found a safe ground to work out their checkbooks, because it borrows a lot of application on the same. And therefore, in this hour, we are going to discuss how to deal with AP and GP exhaustively, and by the end of it, all of you will agree with me that it is easy to deal with. Now, I want us to focus first of all on AP briefly. And I want to say it is an arithmetic progression. A progression can be a sequence or a series. Can be a sequence or series. It can be found in our screen if you focus on that. And if you look at a sequence, what is a sequence? A sequence is just a listing of numbers. That's a listing of numbers, but the series is the addition, the sum. Series is sum of the numbers. So the difference between a series and a sequence is that a sequence is just listing. For example, you could have a list of 5, 7, 9, dot, dot, dot. Class, this is a sequence. This is a sequence. But if you have it as 5 plus 7 plus 9 plus dot, 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 class, this is a series. So this is a sequence, and this is a series. Now, having said that, I think we have now differentiated between a sequence and a series, and now we want to focus more on AP, or what we are calling arithmetic progression. I don't know, I think I should bring both back to back. We bring a comparison, and then from there we can now focus individually on each of them. I want us to compare them, because when we bring out this difference, it will take us a long way to help us understand and see what we really want. If we have an AP this side table and GP this side, so that we move back to back, if you look at the screen, you can see that table well differentiated. AP has common difference D, difference, normally called D. GP has common ratio R. All right, that's one difference in comparison. The other thing that you'll notice is that this involves addition. But this one will involve multiplication. Okay. So if you notice that, then the other difference that we can also discuss in this case is that if you have a list of numbers, and I want to list these numbers because this is very important for us class to understand. If you have a list of n plus 1, n plus 2, n plus 3, dot, 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 meaning, for instance, 1, 2, 3, 4, this is what I'm listing. So in case I'm saying n plus 1, n plus 2, you shouldn't get worried what I'm talking about. I'm sequencing the numbers. I'm listing these numbers. So having said that, I want to rub the lower part and say, if you have n plus 1 as the next number, n plus 2 as the next number, n plus 3 in that order, then how do you get the difference? D. The difference shall be given by the current value minus the previous value. I can say that again as you check that on your screen. I'm saying the difference shall be given by the current value minus the previous, the immediate previous value. That's what gives us D. So it's n plus 1 minus n. And because this D is common, we are calling it common difference, it can continue to be found in that manner. If you are talking about two consecutive numbers, n plus 2 and n plus 3, then D shall be given by n plus 2 minus n plus 3 minus n plus 2. Anytime, anywhere, you will get your common difference. On the side of GP, where we have common ratio, how do we get the common ratio? The common ratio is given by, if again we list the numbers as we had done, n plus 1, n plus 2, and so on and so forth. The ratio, common ratio, will always be given by current number or value divided by the previous value. So it is n plus 1 over n. And because it's common, as the word suggests, it's common ratio, it can also be given by n plus 2 over n plus 1. And this chain can continue because we are discussing R. We are discussing common ratio R. Having said that, then, we can see the difference, clear difference between an AP and a GP. Then the other thing that we would look at is we have talked about common difference, we have talked about addition and multiplication, we have talked about how to get D and how to get R. Now I want us to get how to get a general term. Now we have a list of values n plus 1, n plus 2, n plus 3. This chain can continue to infinity. How do you get a general term? For instance, in this case, how can I get the 10th term? How can I get the 10th term? The 10th term, now I need to list them down because I have the first term and a common difference in case of a 8p. I have a first term and a common ratio in case of a GP. So it's another difference, so we are still in the column of differences. I want you to focus on how to get the common, the nth term. This is an important value for us in both cases. And the term in AP, and the term in AP will be given by, I have already, you have it on your screen, you can look at it, and the term in AP is given by A plus n minus 1 into bracket D. This formula may not have been provided for you in a mathematical table, as we normally use it to refer, but it is combined in the sum. I'll explain as the lesson unfolds. Nth term means general term. For example, I had listed numbers here, 5, 7, 9. How do we get, for instance, these are the first 3 terms of this AP. Now, the first thing that I want us to agree, how do you tell that this is an AP and not GP? As we were doing in primary school, you get the difference and see whether it is common. 7 minus 5 gives you 2. 9 minus 7 gives you 2. It means this is a common difference because it is coming from subtraction. That's why the word difference comes into focus. Now, it means you can continue telling which is the next value. From 9 we are going to 11. From 11 we are going to 13. From 13 we are going to 15, and so on and so forth. It is very, very clear. In this case, 5 is our first term. We normally denote first term. We normally indicate first term with the letter A in both cases. So our general term or nth term will be given by A plus n minus 1 of D. So A is first term, n are the number of entries, D is the common difference. I can say that again. A is the first term, n is the total number of entries, and D is the common difference. Now, focusing on our example here, our A is 5. Suppose the examiner wants us to get the 15th term. Suppose the examiner wants us to get the 15th term. How do we go about it? It simply means that our n is 15. In that case, my A is 5 plus n minus 1, 15 minus 1 into bracket. What is D? We found our D as 2. we found our D as 2. Then you using your calculator or otherwise, you can always calculate, work out the bracket. 15 minus 1, you get 14. You multiply that by 2, you get 28, and then you add 5 to get 33. It is suffice to say that the 15th term in this particular sequence, the 15th term in this particular sequence is 33. Now, suppose somebody argued and said, I think Mwalimu, we can list 15 terms, they are not so many. But suppose somebody wanted the 60th term. Suppose somebody wanted the 60th term. Now this becomes a bigger chain. Requires us to use the formula, to apply the general formula. And so we are saying that the 60th term shall be given by A plus 60 minus 1 into bracket D. In that case, our A remains to be 5. Our N is 60 and our D remains to be 2. In that case, we have 5 plus 59 multiplied by 2. And from your calculator, I'm sure all of you have your calculators with you. 59 times 2 gives you 118. Then you add 5 to get 123. You get 123. Good. Basically, that's how we work out the nth term. Let us go to the nth term of a GP. It is well provided for us in the screen. How do we get the nth term? The nth term, it's an important part for me to emphasize. As you see how I have emphasized it, we are saying that it is given by A r raised to power n minus 1. Again, this formula is not provided for in the mathematical table, but it is important for the learner to know it. If that is it, suppose in GP we did not have an example. I think we can list some values to form a search. Suppose we have numbers like 3, then we have 12, then we have 36. 12, how do we get common ratio? It's 12 divided by 3, which gives you 4. It's the same as 36 divided by 12. I suppose, no. I want this to be 3. The first value to be 4. So that this is a 3. And 36 divided by 12 is again a 3. So if we have a list of 4, 12, 36, and dot, our common ratio, as we were emphasizing, it is current value divided by the previous value. All right. That's why I've picked 12 divided by 4 to get me 3. I can also get 36 divided by 12 to get us a 3, which is now common. The word common implies that should we continue with this pattern, at every point we shall continue getting 3, 3, 3, 3, and so on and so forth. Now, having said that, I want us now to consider the usage of nth term. Suppose in this sequence, I told you this is a sequence, it's not a series, and this is a GP because we have seen it has a common ratio. It is a GP because it has common ratio. Now, suppose somebody asked us how to get the 20th term. How to get the 20th term? How do we go about it? We are saying that 20th term shall be given by, how do we get 20th term? We are getting A multiplied by R, which is raised to power n minus 1, where n is the number of terms that we said. So if we are talking about the 20th term, 20 minus 1 gives us 19. So our 20th term will be A, which is 4, multiplied by R, which is 3 raised to power 19. That gives us now the 20th term of that particular GP. So let's work that out. 3 raised to power 19. It's a big number. Then you multiply that by 4. Just a moment. 3 raised to power 19. That's quite a big number. Then multiply that by 4. You get quite a big number. But that's basically how we would do about that. Having said that, I want us now to look at some examples. No, before we go to example, there is one more difference that I want us to bring on board. I want us to bring on board the concept on sum. Concept on sum. Sum is denoted by Sn. In AP, sum of numbers, Sn means the sum of numbers. It is given by n over 2 into bracket 2a plus n minus 1 into bracket d, close that bracket. Now, listen class. This formula, you don't have to cram it. It is provided for in the mathematical table at the back. The beauty of this formula is that if you cut it from that point, how does it form? If you cut it from that point, I hope you can see the focus on the slides. This part forms the nth term. It forms the general term, the nth term. So if this is it, then let me remove that bracket to remain focused on the sum. The sum is given by n over 2 into bracket 2a plus n minus 1 into bracket d. How do we get sum in GP? Sum in GP is given by a into r power n, then minus 1, divide that by r minus 1. It is given by a into bracket r power n less 1, that divided by r minus 1, as indicated on the board. And in this case, this is when r is greater than 1. When r is greater than 1. We have another alternative in case r is less than 1. We have another alternative. When r is less than 1, we have a is 1 minus r power n bracket over 1 minus r. We have it as a into bracket 1 minus r power n, all that divided by 1 minus r. This again is when r is less than 1. While we are at that point, I think it's important to say something, that in case r is less than 1, in this is less than 1, this would be a smaller number minus a big number. It would give us negative. So in avoidance of that, that's why we have the two options. That's why we have the two options of the formula interchanged as indicated on the board. Having shown those differences, I now want us to embark on a very important exercise of doing examples. We want to do several examples so that we see how do we apply, how do we push this formula into application. All right. I think now we are conversant with our formula. Let's use them now. All right, those are the differences, and it was important that we highlight them. I want us to consider example number 1. Example 1. Example number 1, I want us to consider this pattern 5, 8, 11 as indicated on your screen. Now the question is find D. Find D. D is our common difference that we agreed. And we have already said, how do we get D, class? We normally get D by the current value minus the previous value. What is our current value? Let's take 8 as our current value. We are going to get D as 8 minus 5, which is 3. If you want to confirm that, you can take 11 minus 8. You'll still get a 3. So if somebody asked what is the common difference, it's basically subtracting that. The other thing that I want us in this question, they have told us to find D. I also want to add another part to that question. I want us to find the 10th term. We want to find the 10th term. That's a general term. If this pattern continue, what will be the 10th value? How do we get that? It shall be, we said that nth term, as I had indicated in the formula, nth term is given by A plus n minus 1D. Our A happens to be 5, our D is 3, and our n is 10. If we have these 3 elements, then this sum is done, because we are saying A is 5 plus 10 minus 1 into bracket 3. Take your calculator, open the bracket first. 10 minus 1 is 9. Multiply that by 3, you get 27. Then you add 5. This is 5 plus 27, giving you 32. This means if we listed these values, 5, 8, 11, blah, 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 to the next ones, the next value, the 10th value will be a 32. That's the implication in that case. I think that's very clear. And unless there is a question coming through from the members. All right, can we do example 2, if that is understood? We are doing examples in AP first, then we shall do examples in GP. Example number 2. Example number 2. I hope I am clear in terms of voice. Everybody can hear us. Example number 2. Example number 2. It is already on your screen. Please look at it. We want to consider an example that has a sequence 3, 7, 11. Let's look at that. 3, 7, 11. I have a question for you learners. Is this an AP or a GP? Is this an AP or a GP? It's a sequence. Is it an AP or a GP? What you look at to be able to answer that, you first of all test the differences, see whether they are common, and you test the ratios and see whether they are common. In this case, 7 minus 3 gives you 4. 11 minus 7 gives you 4. So to me, this is a D, a common difference. Suppose we tried to get ratios. It will be 7 divided by 3. 7 divided by 3, I am getting to 7 over 3 or 2.333. I want to see whether it's the same. 11 divided by 7 is 1.57. So in that case, that is not a common ratio. So automatically, our problem is an AP. If it's an AP, then, if it's an AP, how do we go about it? Now let me bring in the question, because I had not written the question. I just listed the sequence. They want us to find the common difference. Find the common difference. Find D. And the 20th term. We want to find D. and then we find the 20th term. Let's do that. D, we have already found. We have said it is 7 minus 3, which is 4, or 11 minus 7, which is 4. So our D is 4. Then, what is our 20th term? What is our 20th term? Our 20th term shall be given by the formula A plus n minus 1 of D. We have A, our A is 3. We have n is 20, and D is 4. So we just replace those values. We have 3 plus 20 minus 1 into bracket 4. Take your calculator. I have mine. I have 19 times 4. That is 76. You add 3 to get 79. So we can say confidently that our 20th term in this particular sequence is 79. Good. We can look at another example. I hope we are clear in that particular case. They can ask you 10th term, 20th term, 100th term, whichever value they want. Just fix it into the formula and you will get the right term that they want for us to give. Having said that, I want us to do another example, number 3. Example number 3 is on our screen, well displayed. Let's look at it. Example number 3, the sum of the first 10 terms, the sum of the first 10 terms of an AP is 400. Just listen to that. The sum of the first 10 is 400. Then the sum, if the sum of the first 6 of the same series is 120, sum of the 6 terms is 120. What does the examiner want? He says we are told to find the 15th term. Find the 15th term. Now, in our solution, this is what we are going to do. In our solution, this is what we are going to do. We have been given the sum of the first 10 as 400. We are given the sum of the first 6 terms as 120. How was the sum of the first 10 terms found? Sum of the first 10 was given by A, not A, Sn is n over 2 into bracket 2A plus n minus 1 into bracket D. That's the general formula. If our n is 10, so what is 10 over 2? It is 5 into bracket 2 into A. We do not know what A is, plus 10 minus 1, that is 9, multiplied by D. We do not know what D is. This should give us 400. That is the first equation. The second one, how many terms are there? 6 terms. 6 divided by 2, 3. Into bracket, 2A, the formula remains, 2A plus n minus 1. Our n is 6, so 6 minus 1 is 5. D, this should give us 120. Now, class, we have 2 equations here. Let us open these brackets and see what we got. In that case, we have 10A plus 10A plus 45D equals 400. The other one, we have 6A plus 15D equals 120. What do we have? Please notice, class, that these are 2 equations, linear equations, and for us to solve them, we need to solve them simultaneously. For us to work them out, we need to solve them simultaneously. Now, do we remember how to work simultaneous equation? As I've always told you, members, mathematical concepts are not tested independently or independently or in separation. They are tested as combined concept. Now look, we were doing AP and GP. What has come our way? Simultaneous equation. This is the work that we did in Form 1. So we need to touch base on Form 1 work. Now, let us solve them. I want us to solve them by elimination. I want us to eliminate D. I want us to eliminate D. For us to eliminate D, we need to multiply the second equation by 3 so that we have 18A plus 45D giving us 360. Then we subtract the first equation minus second equation. 10A minus 18A. 10A minus 18A gives me negative 8A. 45D minus 45D disappears, so it is plus 0. Equals 400 minus 360. 400 minus 360, you are getting a 40. If that is the case, then you have minus 8A equals 40. Your A is 40 divided by negative 8. 40 divided by minus 8, you are getting negative 5. Thus, we already have our A as negative 5. Our A is negative 5. We need to go back to one of the equation to get the value of D. I'll use the second one that says 6A plus 15D equals 120. We have gone back to the second equation. 6A plus 15D equals 120. We replace A with the negative 5 as we have found out. Then we have 6 into bracket negative 5 plus 15D equals 120. In that case, this is a negative 30. So you have negative 30 plus 15D equals 120. Negative 30 crosses over to the other side. It becomes positive. So you have 15D equals 150. 15D equals 150. If that is it, what is the value of D? You divide by 15 both sides, and your D is 10. Is that so? Yes. Now, what did the question want? They wanted us to get the 15th term. They wanted us to work out the 15th term. Our A is negative 5. Our D is 10. And the term they want is the 15th one. 15th term shall be, we can do that. 15th term shall be A plus n minus 1 of D. Our A is minus 5 plus 15 minus 1 of 10. In that case, just take your calculator and punch in those numbers. That's 14 times 10. That's minus 5 plus 140, giving you 135. Giving you 135. Is that clear? I know it is very, very clear. I think from that we can do some examples in GP, because we are talking about AP and GP. I want us to look at examples in GP. We can rub now this, hoping that there is no question, and if there is one, you can just allow me to know so that I attend to it immediately. Now, example In GP, you can do some 2 examples there. Example number 1, because we already talked about what GP is. Example number 1, we have a list of numbers. We have a list of numbers. Consider the sequence 4, 12, 36, 4, 12, 36, ... They want us to find the 5th term and the nth term. Find the 5th and nth. Nth term is general term, so don't be worried by those wording. Nth term simply implies the general term. All right, we can get the 5th term. First of all, we need to find out, is this an AP or a GP? I told you how to go about that. How do we go about that? How do we go about that? We shall do that by dividing current divided by the previous. So R equals 12 divided by 4, which is giving us 3, or 36 divided by 12, which is giving us a 3, and therefore we have our R, we have our radius, we have our common ratio R as 3. If we have R as 3, our A is 4, our R is 3, and we want N as 5. So what is the 5th term? Our 5th term will be given by A, R raised to power n minus 1. In that case, that is 3. Let me change the pen so that we see whether you can see them. A is 3. Our A is 4 multiplied by R, which is 3, raised to power 5 minus 1 is a 4. In that case, you take 3, you raise to power 4 first, you get an 81, then you multiply by 4, and you get 324. So we can say confidently that our 5th term in this sequence is 324. What is the nth term? Nth term is general term. General term, we said that it is given by A, R raised to power n minus 1. We have A, we have R, but we do not have N, because N we do not know what it is. It can be anything. In that case, our A is 4, our R is 3, raised to power n minus 1. So our general term can be left in that manner. Our nth term can be left in that manner as 4 into 3 raised to power n minus 1. Having said that, I think we can look at one more example in GP. Let's look at another example in case there is a question. I should be informed accordingly. Seems there is none. Let us do another example, second example in GP. Second example in GP. I want us to consider a set of data. It is well provided for us. The ratio of the 10th to the 8th term in a GP is 9. A very good question. These are kind of questions they'll always bring for you at the NEC or KCSE exam. They are telling us the ratio of 10th to the 8th term of a GP is 9. Clearly, they have told us what is AP, and they have told us this, our case is an AP, the ratio of 10th term. How do I get 10th term to that of 8th term? How do we get 10th term? 10th term is A R power 9, because you remember the general term is a r power n minus 1. So if n is 10, you less 1, you are left with power 9. The eighth term will be a r power 7, because again it is 8 minus 1, you are left with power 7. They are telling me this ratio is 9, simply meaning ar power 9 over ar power 7 is the same as 9 over 1. This is basically what they mean, that the ratio of 10th term to that of 7th term, 10th term to that of 8th term is 9. 9 can be written as 9 over 1. In that case, 9 over 1 has become a fraction so that we can operate. Now you need to listen to this. Members, these two numbers are held together by multiplication. If numbers are bound by multiplication, they can be divided. If they were held by addition or subtraction, they cannot be divided. So in our case, they are bound by multiplication. So in the numerator and denominator, a is common. You first of all cancel or divide a, both sides. You are left with r power 9 over r power 7 equals 9 over 1. Now, there is a concept we taught you in Form 2. We taught you that in indices, when you divide numbers, what do you do to the powers? When we divide the numbers, you subtract powers. So in this division, it shall be r raised to power 2 equals 9 or 9 over 1. So finally we are here, we have r squared equals 9. Can we know r? Because they want the common ratio. R, you get the square root both sides. To get r is plus or minus 3. Our ratio, common ratio, is plus or minus 3. That's why the question asked, find the two possible common ratios. Find the two possible common ratios. We knew there would be two. The mistake our learners will make many times, every time you get square root of a number, you give the positive number. Allow me to emphasize to you in this lesson that every time you take a square root of a number, there are two possible answers. There are normally two possible answers, the negative of it and the positive of it. That's why we have r, our common ratio, as positive 3 or negative 3. And I think that point is well driven, because it's an important point for us and we need to emphasize it every now and then. Good. I think we can do the last example. We can do the last example to allow us also catch up with this case. I want us to do example number 3 on GP. Example 3 on GP. Example 3. I want us to consider a KCSE question that was examined some times ago. It says, in a GP, the first term of A in a GP, the first term is A and the common ratio is R. The first term is A and common ratio is R. The sum of the first two terms is 12. The sum of the first two terms is 12. It is a GP. The sum of the first two terms, so we have A plus A R. This is the first term and the second term. The sum of the first two terms is, the sum of the first two terms is 12. All right. And the third term is 16. Third term, which is AR power 2 or AR squared, is 16. Now they are asking, determine the ratio. They want us to determine the ratio AR squared over A plus AR. Determine the ratio AR squared over A plus AR. In this case, what it means, simply, I think we can factor out A in the denominator because it is common. I'll have AR power 2 over A into 1 plus R. And in this case, we can cancel A. I'm left with R squared over 1 plus R. This is the ratio. This is the ratio that we have, that we are talking about. And we can leave it at that point. Because I want to see whether you can tell first term, second term, third term, and form equations of that nature. And that's what we have just done. Now, they are saying if the first term is larger, than the second term, implying that R is less than 1 because it is a reducing GP. If the first term is larger than the second term, find the value of R. We find the value of R. We can come back here and say that this over that, because this is what we had R squared over 1 plus R equals 16 over 12. We cross multiply them. We have 12. R squared equals 16 into 1 plus R. Now, we open the bracket. We end up with 12 R squared equals, this is implication, equals 16 plus 16R. In this case, we bring all this stuff to this side. 12R squared equals, minus 16R minus 16 equals 0. Class, if you look at this, it has become a quadratic equation. Who knew that in AP and GP we would end up with quadratic equation? Again, I'm emphasizing these concepts are not tested in isolation. They want us to solve this quadratic equation. Let us do that very fast. We have 12R squared minus 16R minus 16 equals 0. We want to solve this. We can simplify it by dividing by 4. 4 is common. So we have 3R squared minus 4R minus 4 equals 0. I am going to apply the formula. So it says that x equals minus b plus or minus square root of b squared minus 4ac, this divided by 2a. Don't ask me where I got this. It is from mathematical table. It is well provided for in our case. So in this case, if you work out the value, you will get our R shall be 4 plus or minus square root of b squared, that is 16, minus 4 times 3 times negative 4, divided by 2 times 3. In that case, our R is, let's do that very fast. Our R shall be 16 minus bracket 4 times 3 times negative 4. 64 square root, answer is 8. So this is 4 plus or minus 8 over 6. In that case, it is 4 plus 8, 12, divided by 6, that is 2. Or 4 minus 8, which is negative 4, divided by 6, is negative 2 over 3. Allow me to rub this a bit for us to see. I have worked it out, and our values of R is either 2 or negative 3. But remember, the examiner said that the first term is larger. So in that case, our R is negative 2 over 3. That will mark the end of our lesson today, and I hope you have learned how to workout, AP, and GP, and they have very wide application in real life situation. So we shall continue from there in the next lesson. We shall continue looking at more examples, so do not stop there. Mathematics is a doing subject. It's not an observation. Keep doing them. I have given you outline. Go out there and practice, and it shall be great because you'll be able to solve them. Wonderful.